All right, so this right here is step 8 for the project that we're doing in class. So the first part of the step is for step 8, it talks about if the objects were dropped from a significant height. It wants us to create and solve an integral equation to determine the time needed to reach terminal velocity and also the distance needed to reach terminal velocity. So right here, I wrote a free body diagram, the force going up, the weight going down, which equals mass times gravity is equal to mass times acceleration. And then we also use this equation, this linear equation here too. It can also be mx plus b, and that's from the graphs that we did in step 7. This is where we get that equation for each profile. And then a equals dv over dt. This will help us get the time. And then a equals v dv over dx, which will help us get the distance. All right, so right here we're solving for the time. We get the sum of forces in the y direction, which will be mg minus ft equal to ma. Then we substitute a for the dv over dt, get dt by itself, send this to the other side, and then we finally integrate it. Here's the steps of how I integrated it. I did it by parts. And then our final answer will be this right here. So this equation right here will be our the equation we will use to find the time. M is mass over B. B is part of the linear equation, and then mass times gravity minus C. C is also part of the linear equation. And then VT is the thermal velocity. All right, and then to get the distance, same thing here, but instead of substituting a by this, we substituted by v dv over dx. We integrated, and I got this long equation right here. All right, and that concludes steps parts A and B for step 8. And then for step C, it wants us to determine the terminal velocity for each profile. So here I wrote down the linear equation for each profile right here. And then to figure out what terminal velocity, it's when acceleration equals 0. So from this previous right here, from this equation right here, we used it to get the terminal velocity, which is mass times gravity minus c over b. So we use that equation for each profile to get our velocities. And this is our velocities our terminal velocities for each profile. And all we did is just substitute the values for the mass and the values that we get from the linear function. Now for step D, it wants us to determine the time to reach 50%, 90%, and 99% of each terminal velocity for each profile. So for example, I'll just real quickly talk about the sphere profile. So the 50%, we use the previous equation from step A, which is right here. Plug in all the values that we know all the values, and then but in the part of the equation where we have to plug in the terminal velocity, we do the terminal velocity times 50%. Plug that all in, and we get 0.110 seconds. And then we do the same thing for 90 and 99%. The only difference that we just changed this little part right here to 90 and 99, and this is the values we get. Yeah, and that's how we got for the golf ball. Same process. The cylinder for the long side, cylinder for circular side, block large, block small. We all did the same steps for those. And then for part E, it wants us to find, it's the same as part D, but this time they want us to find the distance, and they want us to find it for 50%, 90%, and 99%. So again, we use this long equation that we solved before, but what I'm gonna solve beforehand is the mg minus c. So I'll use the sphere for an example again. So mg minus c, we figure it out, we get this right here. Plug it in into the equation we solved for. We know all the values, and then again, wherever there's the terminal velocity in the equation, we do the terminal velocity times whatever percent we're solving for. This time is 50%, so 0.5. Also right here, and we get our final answer to be 0.048 meters. Then for 9%, just substitute this with 90, 99 substituted by 99, and we get this for a distance. Yeah, and we do the same thing for the golf ball. Cylinder long side, the cylinder circular side, the block large and the block small. All this right here is what we did. It's the same exact same steps we did for the sphere, just plug in the different values for each one. Yeah, and that calculates that. That is the last of step 8, and that concludes the project that we've been working on.